Hi everyone, I'm recording this video to show you some of the information about the final exam 1, and then after that I will show you a couple of the sample questions. Okay, so let's start from the information of the final exam. Okay, if you remember what information we have on our syllabus, you may remember that we are going to have the final exam starting from starting from the noon of the May 4th. And later, after talking to a couple of the students and also the director of the graduate program, I decided instead of giving you guys 12 hours, I will give you 24 hours instead. So you will have a whole day. And our exam will start from the noon of the May 4th, and the submission locker will close on May the 5th at noon. Okay, so this will be a take-home exam, and remember it's individual work, so you can't really work together with your buddy. And the resources you are able to use or you're allowed to use are the lecture notes, your own notes, and your own code, the lecture videos, and if you want to use a textbook, and that's also fine. So I can't say this exam is 100% closed internet because, if you want to see the lecture videos, feel free to do so. However, if you want to search a question online or you want to share files, or if you want to do other people's exam or exchange emails to have discussions, that is not allowed. Okay, and another reminder is you need to find a handy visualization tool for some of the illustrations because we are gonna cover everything we have learned in this class, and we will focus a little bit more on the graphs. So for the graph algorithms, then I may ask you to trace trace a algorithm given a graph, and in this case you may have to show me the illustrations. And if you have a handy tool, and that will be terrific. And otherwise, if you want to do the hand drawings and then take a photo and then paste that into the PDF, and if that's not really readable, you are going to receive a 0. Okay, so I highly recommend you to find a handy tool by yourself. And then for the simple questions I'm about to cover in this video and the next couple of videos, and if you have the plan to do the visualization by yourself, just to test out some of your visualization tools, and that would be a good idea. Okay, so let's start from the first one. So the first thing we talk about is a graph representation. And for the graph representation, and if we want to show the adjacency list, and how can we do that? Okay, so this is a graph, this is an undirected graph, and then let's say if I want to do the graph representation, let me get rid of this one. Okay, and then let me paste it in. Okay, so for this one, if we want to create a adjacency list, and an adjacency list can be considered as an array of arrays or an array of linked lists. Okay, so let me try to do that with using an array of linked lists. So we have a total of 0 to 8, so a total of 9 nodes, right? So let's see if I'm gonna start from 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so if I consider this as an array, this as a list, and for each slot, it will give you a reference of the nodes that are connected to the 0 or 1 or 2 as a start point. Okay, so let's start from 0. From 0, where can we go? We can go to 1 and 3 and 8. Okay, so we can go to 1, and then the next is a 3, and the next is an 8. And if you want to go to the next, and you will find a none here. Okay, so this is the slot 0 or a index 0 will be the start or the head of a linked list. And in this linked list, and we will have all the nodes that we can go from 1 to node 1 can bring us to using one hop or one edge. So starting from 0, we can go to 1, we can go to 3, we can go to 8. Okay, if we want to do the node 1, from node 1, we can go to 0. We can also go to 7. Okay, and how about node 2? From node 2, we can go to 3. We can go to 5. And we can also go to 7. Right? Okay, so I'm going to stop doing this question here, and let me remind you one thing. So for this question, I didn't really ask you to list all the adjacent nodes from the index low to high. Okay, if I didn't say that, say for the node 0, we do 1, 3, 8. That's okay. If you want to do 3, 1, 8 or 8, 1, 3, they are all fine because I didn't really tell you how those nodes are going to be listed in the linked list. Okay, well, for this question, if I only ask you to do a graph representation using using adjacent list, and that is 100% fine. However, the problem is, well, if I ask you to create the adjacency list using this graph, and I didn't tell you how those adjacent nodes should be sorted. And later, I ask you to apply an algorithm, for example, BFS or DFS, and now we will have the problem because the sequence of the nodes are different, and it's likely that we are going to have different solutions. So, well, for my rule is, if I ask you to create a graph representation using linked list or adjacency list, and then I usually will tell you for all the nodes inside the linked list, and you should sort all of the nodes from low to high. And in this case, if we are trying to find the neighbors using the 0, and then it's guaranteed that the neighbors we are going to visit of 0 will start from low to high. So we're going to start from 1 and then 3 and then 8. Okay, so this is the first question we talk about adjacency list. Okay, so I will see you in the next video.